Now let us discuss an example of divisibility test question that was asked in CAT 1996. Question is, if a number 774958A96B, where A and B both are digits from 0 to 9, is to be divisible by 8 and 9, then respective values of A and B will be. There are four options given. This was asked in CAT 1996. CAT 1996. Now let us see. The given number is 774958A96B. This number is divisible by 8. If a number is divisible by 8, that means last three digits must be divisible by 8. That means 96B is divisible by 8. Now, if you do the actual division by 8, we will find 1, remainder is 1, 2, 16. That means which value of B will satisfy this condition? If B equal to 0 or if B equal to 8. So this number is divisible by 8 when we have B equal to 0 or B equal to 8. That means we have two values of B, either B equal to 0 or it is equal to 8. Now it is also given that this number is divisible by 9. Now we all know if a number is divisible by 9, then summation of the digits must be divisible by 9. So now we will find out the summation of digits. 7 plus 7, 14. 14 means 1 plus 4, 5. 5 plus 4, 9. 9 means carryover is 0. Then we don't add 9. Carryover 0. 5 plus 8, 13. 13 means 1 plus 3, 4. 4 plus 8, 9. We never add. Carryover is 0. 4 plus 6, 10. 10 means 1 plus 0, 1. Hence summation of digits is 1 plus A plus B. Since this is divisible by 9, hence summation must be divisible by 9. So summation must be either 9 or 18. Because maximum value of LHS side is 9 plus 9, 18 plus 1, 19. The summation cannot be more than 19. So we have two cases, when summation is 9 or summation is 18. Let us take the first case, when summation is 9. If 1 plus A plus B is equal to 9, or if A plus B is equal to 8. Now we have two cases, if B equal to 0, A equal to 8. If B equal to 8, A equal to 0. So we have two values of A from this case. Next case is 1 plus A plus B is equal to 18, or A plus B is equal to 17. If B equal to 0, no value of A exists as A is a digit. If B equal to 8, A equal to 9 will satisfy this condition. Now have a look at the given options. 8 and 0 is a given option that satisfies the condition. Hence our answer option is B. Now point to be noted that same question can be asked that this number is divisible by 72. Instead of 8 and 9, they can give us that this number is divisible by 72. Then again we will follow the same approach, because a number is divisible by 72 only when it is divisible by 8 and 9 both. The reason behind this, we all know 72 is equal to 8 into 9, and these two are co-prime to each other. Okay, now let's discuss another example of divisibility test question that was asked in CAT 1998. The question is, a 100-digit number is formed by writing first 54 natural numbers in front of each other as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means one after the other natural numbers are there. Find the remainder when this number is divided by 8. So first of all, how to find out remainder when any number divided by 8? We know divisibility test of 8 is last 3 digit. So the crux of this question is we need to find out last 3 digit of this number. Let us suppose the given number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. This is a 100-digit number. So we need to find out last 3 digit of this 100-digit number. Here in this case it is given that first 54 natural number. Even if it is not given, we can solve this question because we know that n is a 100-digit number. So from 1 to 9 we have already used 9 digits. After 9 each number takes 2 digits. 10 we have 2 digits 1 and 0. 11 again we have 2 digits 1 and 1. 12 again we have 2 digits 1 and 2. That means after 9 each number takes 2 digits. Let us suppose after 9 we have n more numbers. N more number means 2n digits. So total digits we have used is 9 plus 2n. This one is, if we get equate to 100, we'll get n is equal to 45. N equal to 45, then we will get this summation as 99. N equal to 45 means if we write down 45 numbers after 9, then we will get 99th digit, because 9 plus 2 into 45 is equal to 99. Since 1 digit after 9 is 10, 2 digit after 9 is 9 plus 2, 11, 3 digit after 9 is 9 plus 3, 12, hence 45 number after 9 is 9 plus 45, 54. What does it mean? It means when we have written down here 54, the last digit of 54, that is 4, is the 99th digit. Then after this we will write down 55. But this number last 5 is your 100th digit. Since it is given that n is a 100-digit number, that means this 5 is the last digit. Just before that we must have written 53. Hence last 3 digit of this number n is 545. So the remainder when n divided by 8 is same as remainder when 545 divided by 8. The same question can be asked if n is a 1000-digit number and it is divided by 16. What is the remainder? Only thing we have to do in that case, divided by 16, we need to find out last 4 digit. For 32 we need to find out last 5 digit. So just take another example. If n is a 1000-digit number and that number when divided by 100, what is the remainder? Okay, let's discuss a good example of divisibility test. The question is an is equal to 1 1 1 1 1, where 1 occurs n number of times. The question was asked in ZAT 2011, that too it was a 5 marks question. What is the meaning of this expression? The meaning of this expression is A2 is equal to 1 occurred 2 times, or 11. A3 is equal to 111. A4 is equal to 1111, and so on. Then there are 4 statements given. A741 is not a prime. A534 is not a prime. A123 is not a prime. A77 is not a prime. Then which one of these are correct? Now let us look at the first statement. A741 is not a prime. A741 means 1 1 1 1 repeated 741 times. So if summation of digits is equal to 1 plus 1 plus 1 plus 1, 741 times, hence summation of the digits is equal to 741. Now we all know 741 is divisible by 3, because again summation of digit of 7 plus 4 plus 1 is equal to 12, which is divisible by 3. Hence 741 is divisible by 3. Hence this number is not a prime number, because this number is divisible by 3. Similarly, second statement, A534 is not a prime. Just have a look at this number A534. Here summation of digits will be again 534, which again is divisible by 3, because sum of the digits is again 12. Hence A534 is again divisible by 3 and not a prime number. Then statement 3, A123 is not a prime. That means summation of digits here is 1 plus 2 plus 3 is equal to 6, divisible by 3. That means all these 3 statements are correct. This is also not a prime. All these 3 numbers are divisible by 3. Now A77, if you do the same method here, then sum of the digits will be 7 plus 7, 14. It is not divisible by 3. Now it is very difficult to find out at this point A77, and most of the students left this question only because they could not determine A77. But if you have a look at the options, option 1 cannot be the correct, because it says only statement 1 is correct, but we know statement 1, 2 and 3, all 3 are correct. Hence this is option ruled out. Option 2 says 1 and 2 both are correct. So again this one is ruled out. Option C says only statement 2 and 3 are correct. Again this is ruled out because we all know all 3 are correct. So only option D is correct or E is correct. But E says none of them is correct. Again this is ruled out. So only option D is correct. And all 4 statements are correct. So we know option D is correct. Statement 1, 2 and 3 are correct. Hence option D must be correct. All 4 are correct. But my question is how to determine A77 is not a prime number. A77 means 1 is repeated 77 times. This number is always divisible by 1 is repeated 7 times or 1 is repeated 11 times. The reason behind this or the concept behind this, any number x repeated n times must be divisible by x. Hence this A7 where 1 is repeated 7 times must be divisible, divide this number exactly. At the same time this number is completely divisible by A11 also. So if any number x repeated n times, it must be divide x.